calling it polynomials and rational functions. All right, find the X and Y intercepts, determine whether each is even, odd, multiplicity, find the power function the graph resembles, determine the number, turning points. And okay, so we're basically just we're doing basically graphical analysis here. So let me just give you may have learned this already. I don't know how your teacher taught this, but you tell me, stop me if I'm over explaining it or under explaining it, you need more explanation. But basically what you want to think about is the total power. You want to look at the leading coefficient and you want to look at the power or the degree of the function. And that will tell you whether it is what the end behavior is doing. It'll tell you how many peaks and valleys there are potentially. It'll tell you basically all the stuff that they're trying to find, just those two things. So I can see that the leading coefficient in this is positive, right? Can you see that? And yes. In fact, the way you know the leading coefficient is just go ahead and multiply all the first things out. So that's going to be x squared times x squared is going to be x to the fourth times another x is going to be x to the fifth. So this is an odd degree. This is a fifth degree polynomial. And it's a positive leading coefficient. Okay.
Yeah.
And then the multiplicity of each zero. So we can also find the zeros. Let's see, they want us to find the x-intercepts. Yeah, so find the x and y intercepts. That's the first thing. All right, so let me start back at the beginning. Finding the x-intercepts, this is already in factored form for you. So you basically just set each one of those factors equal to 0. X squared equals 0, which means x equals 0, and it's got a multiplicity 2. I'm going to write m2 next to it. And the reason for that is because it's squared. Make sense? You good with that?
Yes. Yeah.
The next one, x squared plus 1 will not yield any real zeros. Those are complex zeros. So there are no x-intercepts from that. You understand what I mean by that?
Yeah.
Okay, and then x plus 4 equals 0 yields a 0 of -4, and that has a multiplicity of 1. Okay, the y-intercepts, so these are the x-intercepts. The y-intercept, there's only one, if any. And the y-intercept, all you have to do is plug in 0 for x. So it's 0, comma, just plug that in and you're going to get 0. So 0, comma 0 is my x-intercept. Okay, so there's my x and y intercepts. Determine whether the x-intercept, whether each x-intercept is of odd or even multiplicity. So we already did that. That's an even, that's an odd. And this, by the way, an even multiplicity means it bounces, it doesn't go through. And an odd multiplicity means it passes through.
Gotcha.
At that point. You understand that?
Yeah.
Okay. And then it says, find the power function of the graph of f resembles for large values of absolute value of x. So that power function is just x to the fifth. That's what it, y equals x to the fifth is that power function that it resembles for large values. And that means it goes up to the right and down to the left. So the end behavior is toward negative infinity. As x goes to negative infinity, y goes to negative infinity. And as x goes to positive infinity, y goes to positive infinity. Understand why? That's this piece right here that I was talking about.
Yeah.
Because it's a positive leading coefficient in an odd degree, it's going to resemble the x to the fifth, or really it's going to resemble x, y equals x even. You can even say that it resembles y equals x. It just resembles a line that goes up from left to right. You understand what I mean by that?
Yeah.
Determine the number of turning points on the graph. Okay, so there's going to be turning points. There's going to be a maximum of 4 turning points. But because of the multiplicity, because of the bounce, see, does that bounce affect turning points? I'm trying to think here. Let me just graph this out and let me think of what the graph would look like. So
Okay.
my intercepts would be 0 and -4. And the end behavior is down and up. So you know it's got to bounce. So it's got to go, somehow it's got to go up through here, and then it's going to bounce through and come back up here. But it could do another bounce somewhere. We just don't know where that's going to be, because because of the imaginary zeros. You understand what I'm saying? So that
Yeah.
means that it's going to plus or minus the square root of -1. That means that it's going to go at some point it's going to do another bounce and come back somewhere. So it could be up here. I'm not sure that they particularly want you to know where that happens. I don't actually know how you can find out how that happens without graphing it or doing some more analysis. But that's what's going to happen. You're going to have one turn there, another turn on the axis, another turn there, and another turn there. So you're going to have 4 turning points on the graph. So the turning points are always, the max and min and turning points are always limited by 1 less than what the degree is of the function.
Okay.
So the I believe that's what they mean by turning points, the max and min.
Yeah.
So here's a turning point, here's a turning point, here's a turning point, here's a turning point. And again, these two might not be here, but they're probably going to be somewhere. Maybe they would be here. But you know it's not going to cross through anywhere other than this point. It's never going to cross through the x-axis anywhere but here. So it could even have been, the turning point could have been down here even. It could have been like that. You understand what I'm saying?
Yeah.
What did your teacher talk about in terms
For
of
turning
this?
points, we didn't actually go that much into depth about them. We just kind of discussed the rule that turning points are 1 less than the degree, like for the quantity of them. And kind of for finding turning points in the middle of the graph, he said he doesn't care that much and is more focused on end behaviors than finding the locations of turning points.
That's what I thought. So it doesn't really matter where they are. They don't want you to analyze that at this point. They just want you to say in general what it's going to be.
Yeah.
All right, good. Next question, the Golden Gate Bridge. All right, so this looks like a fun question here that we're going to do some graphical analysis on as well. Let me see if I can make this a little bigger so that in the YouTube video it's easier to see. Oh, nice job.
Oh yeah, there's an oval covering part of it because it already had a model on it.
Oh, do you not want me to use this model?
I'm fine either way. I just didn't know if it's because I know there are variations in how you can do the model of it.
Yeah, there are variations.
Because we were given a couple, so I didn't know which one is like a better model to use, although I know they both work.
Yeah, I always like to do what this model shows, which is to put your origin right at the vertex of your parabola. That just always makes it easier. So let's just use this model that they did. This was included in it?
Yeah. Well, it was included as part of our teacher's work for it.
Oh, okay, good. So let me just explain how this works. So it says it spans there's a 746 foot tall towers are 4,200 feet apart. So here's the tower right here. And the other tower, and here's the 4,200, but notice they're putting it they're centering it at the bottom of those cables. So they're putting the origin at that cable and they're putting it right in the middle of the bridge, which is obviously where it would be. So it says the bridge is suspended from 2 huge cables more than 3 feet in diameter. That doesn't matter, the 3 feet in diameter, just so you know. That was a Fuller piece of information. The 90-foot wide roadway, so this is 90-foot wide roadway here, which probably doesn't matter either, is 220 feet above the water. So that matters. That matters here because that tells you where the center of the bridge is, or where the pavement is.
Mhm.
So it says right here that the cables are parabolic in shape and touch the road surface at the center of the bridge. That's important information. So we know that the cables touch the road surface right at the center, right there, they touch it, and it's parabolic. And so these pictures are correct. So what you need to do is subtract 200 from this number to get this point up here and this point up here. So here's, if this is 0, 0, then this total distance is half of 4,200. So it's 2,100 to the end. That's how I got 2,100 as the X coordinate and negative 2,100 at the Y coordinate. And because this is 220 feet to the water, we knew that we subtracted that from the pole's height and we got this distance above the X axis as 526 on both sides. And now that we have that, we can write an equation more easily because we have 3 points. And actually, really, all we really need to do is use this equation: y equals a times x minus h squared plus k. We already have h and k as 0 and 0. So all we have to do is find a. And the way we can find a is we can plug in your x and your y from any one of these points, just not 0, 0, because that won't do anything for you. So let's take this point, 2,100 squared, a equals 526, that's your y, and then just solve it. So a equals 526 divided by 2,100 squared. You don't even really need to clean that up at all. You can literally just leave it like that. Y equals 526 over 2,100 squared times x squared. So now the question is, first of all, do you understand how I came up with that equation?
Yes.
Okay. So the next question says, find the height of the cable at a distance 100 feet. So this is your x. This is your x. So I'm plug in, I'm sorry, 1,000 feet. I said 100. So I plug in 1,000 now for x. And I solve that equation for y. And that will give me the height. So 1,000 squared is on the top. 2,100 squared is on the bottom. I'm just checking to make sure I did these right. Hopefully that's going to give me the right answer. So punch that into your calculator. Did you try that?
Give me a second. I can type it in.
Actually, I can try that because I can see it on my
Oh,
screen.
perfect.
I'll do it right here on Desmo. Actually, you know what? I'll do it on the graphing calculator because that'll be easier. So 526 times 1,000 squared equals that much, and then divide that by 2,100 squared. 119.27. And that actually checks out. Is that the right answer, do you know?
I think so.
119.27 feet. And that makes sense if you look at it. If you look at that distance there, remember it's a parabola, so it's going to go up. It goes up steeper the further you get to right. It goes up steeper. So this is not that far from 120 feet compared to the total height, which is 526 feet off of the top of that bridge. So that makes sense. Seems about right.
Yeah.
Okay, good with that?
Yep.
And no questions on how we did that? You're good?
Yeah, I'm good.
Okay. This next one said factor each, real numbers only, may require synthetic division. Okay, thanks. Plot the zeros and the y-intercept and predict the graph, not using a calculator. Okay, so the first thing that recognize that to factor this means that I'm going to have to try to figure out what, because there's no factoring that I can do. There's no factoring that I can look at and see, oh yeah, it's going to be this or it's going to be that. The thing to do is to try to figure out, is there a number I can plug in here and find a 0. And I'll tell you right now, I can see a number that you can plug in, and that number is -1. If I plugged in -1, and see, I know that -1's a good possibility. If I plugged in -1, can you see that this is going to be a -1 here? That's going to be a -1 here. That's going to be a -4 there, and that's going to be a +6 there. So that means -1 is a 0. That's what it means to be a 0. Now, if you didn't know that, what you could do is you could just use synthetic division like this and take those coefficients, right? Are you good with synthetic division? And you can just start plugging in different, try 1. Let's see if 1 works. Bring the 1 down, multiply, add down, multiply, add down, multiply. Nope, that didn't work because that didn't give me 1. Sorry, 0. I'm looking for 0. So now let's try -1. Well, this is -1. That's a negative, and then this is. I'm sorry, I did that wrong. If that's a -1, this is a negative, and that's a -5, and this is a +5, and that's a. Oh, hold on, I'm doing something wrong here. -1 should work. Here, let me redo this. -1 is a 0. I know it's a 0. So let's see, I'm plugging in these things right. So bring the 1 down, multiply, and write that here. Add down. That's a -5. Oh, there we go. Multiply, and that becomes a +5. Add down, that's a 6. Multiply by the -1. And that becomes, sorry, -6. That becomes a 0. You good with that, or do you want me to explain that process, synthetic division?
I'm good with it.
Okay, so now this gives you your other factor. So basically what I know is that this equals x plus 1, because that's the -1, 0, right? Times x to this x squared, because that's the 1, minus 5x plus 6. And so now I can try to factor this further. And I know how to factor this if it works, right? It's x minus 3 and x minus 2. Did that work?
Yeah.
It sure did. So this actually equals x plus 1 times x minus 3 times x minus 2, which means my zeros are at -1, +2, and +3. Those are my zeros. And now the y-intercept is just going to be 6. 1, 2, 3, 4, 5, 6. The y-intercept is going to be 6 because it's always just this number here in standard form. And then predict the graph. Well, I know, remember end behavior, it's an odd function. It's an odd degree function. Sorry, it's not an odd function. It's an odd degree function. And it's positive leading coefficient. So I know this end's going to be going up and this end's going to be going down. So my rough sketch of the graph is going to be, and all of the multiplicities are 1 or are odd, right? So my rough sketch is going to be something like this. It's going to pop up here, it's going to come down there, and it's going to come back up there somehow. That wasn't very pretty. It's probably going to be something more like this. But that's going to be my graph. Roughly predicted. Good?
Yeah.
All right, stop me if you're confused. It seems like you're understanding it, but if you're not, please do tell me.
Okay.
All right, the next question. For the polynomial function, list each real 0 and its multiplicity. Okay, so let's just do that quickly. So the real zeros that I have here, I've got x squared equals 0, and I've got x squared minus 2 equals 0. So one of my zeros is x equals 0, and the multiplicity is 2 for that one. And then my other zeros, I actually have the zeros of x squared equals 2. So I have x equals plus or minus the square root of 2. So each of those has a multiplicity 1. right? So x equals the square root of 2 with multiplicity 1, and x equals negative square root of 2 with multiplicity 1. So there's my 4 zeros if I count multiplicity. 1, 2, 3, 4. List each zero and its multiplicity. Determine whether the graph crosses or touches the x-axis at each intercept. Well, that's easy. It touches here, or I like to say bounces, and it crosses here and here because of the multiplicity. Yes?
Yeah.
Determine the maximum number of turning points on the graph. Well, that's just going to be 3. It's always 1 less than the degree, and the degree is 4. And determine the end behavior. So it's like the y equals x to the 4th. That's your, and it's a positive one. So the end behavior is up on both sides, up on the left and up on the right. Okay, so it didn't ask us to sketch the graph, but normally it would. So I'm just going to do it. So negative root 2 is like somewhere between -1 and -2. And positive root 2 is somewhere between +1 and +2, and 0 is right here. So if it goes up like this on both sides, you know it has to bounce here. That means it has to do something like this. That's what my graph's going to look like. Okay?
Yep.
Graph this function. Okay, well, I can graph this one by factoring it. It's going to be x squared, -4, and -1. Because you see how it's in, see how this is, this looks like a squared in the first power, but it's the 4th and the 2nd. So all you have to do is just make that squared, and usually it'll work. And then you'll see that negative times a negative is a +4, but it adds to -5. So this means, look how nice this is. My zeros are x equals ±2 and x equals ±1. So I actually have all of these zeros, 1, 2, 3, 4. And it's the end behavior is up and up. And there's no bouncing. So you know it's going to do this. Something like that. You don't know how high it's going to go in the middle here. But you can find out how high. Oh, wait, yeah, we do. It goes up to 4 because the y-intercept is 4. You see that? So that actually gave us all the information we wanted. There's our graph. Let me make it red. Okay.
Yep.
For the polynomial function, list the real zeros and its multiplicity. So we've got, I'm just going to write them. We have a real zero of 2 with multiplicity 1. And we have a real zero of -7 with multiplicity 2. Right?
Yeah.
Let me write M2 so you're not confused, because I've been doing that. M2, multiplicity 2. Determine whether it crosses or touches. So this touches here, and it crosses here. Determine the maximum number of turns. So that's going to be 2, because it's 1 less than the degree, which is 3. And determine the end behavior. So since it's a negative, it's going to go down from left to right. So up on the left, up to the left, down to the right. Okay.
Yep.
-x³ is the function that it resembles at the ends. Or again, just -x, you could even say. Graph it. Okay, so this is one like the other one that we had, right? So you're gonna have to find the different points and try to figure out. So if you can just look at it and see what number you can plug in here, that will make it work. Like I'm thinking maybe a 2 will work here, because that's going to give me -24. And let's see, this is 8 and 2, 4, 16 and 8. Yeah, look at that. 2 worked. You see how I did that?
Yeah.
So I know, so all I'm saying is use that. You just do some quick mental math if you can, And that will save you from having to just guess and check a bunch of numbers. So I know 2 is going to work. So 1 comes down, multiplies, adds, multiplies, adds, multiplies, 0. There we go. So x squared plus 6x plus 10. So does that factor some more? 5 and 2, that doesn't factor anymore, does it?
No.
I don't see that factoring anymore. So this is what that is. It's x minus 2 times x squared plus 6x plus 10. So to graph that, well, you could find zeros by using quadratic formula here, perhaps. And at least you would know if it has plus, positive or negative zeros, right? So I know one of them's at 2. And the other one would be, let's see, negative b plus or minus the square root of b squared minus 4ac. So it's not going to have any more because that's a negative. That's a negative discriminant. Determinant or discriminant? I forget which one that is.
I think it's discriminant.
Discriminant, yeah. So this has none, no zeros, or I'm sorry, no real zeros. It has 2 imaginary zeros, but no real zeros. So we know that it's going to go up from left to right, and there's going to be some crazy stuff, but it's only going to cross the x-axis. Well, the y-intercept is negative 20, so it's way down here. So it's going to do something, who knows what it's going to do, but it's going to basically go like this, probably, something like that. So they said graph it, but really there's not much you can do to graph it without a graphing calculator, except for plugging the 2 intercepts and recognizing that the zeros are, that it's going up from left to right. Okay.
Yeah.
Sound good?